Hello everyone, my name is Timur Weilbach-Eyüboglu. As mentioned, I'm from Munich and presenting a semantic framework for formalizing stakeholder information requests in construction. Now, to start this off, I want to ask a simple question. Is foundation of one ready for concreting? Now, this is not a research question. This is a typical question you get on construction site at a Tuesday afternoon. And a team simply wants to know whether they can continue with their work. Now, at first it sounds very simple, but when we try to answer it, we'll realize that the evidence is scattered. So, for example, the BIM model tells us what and where foundation of one is. The reinforcement bars needs to be approved by a structural engineer, and on top of that, we have to check the weather if the conditions are right. So the answer to this question does exist, but not in one place. And this is a practical problem, since the manual effort of collecting and connecting all this evidence to answer this simple question is very time consuming. And now this gets even more interesting if we look at other questions that practitioners have. They use different words and refer to different objects, documents and activities, but they all create the same situation. So someone needs decision relevant evidence from distributed project information. And so the wording varies here, but the need is recurring. And once we get rid of the wording part, we see that patterns start to appear, like completion, tolerance, approval, and readiness. So these are not random one-off searches. They are recurring question types with placeholders, like the activity, requirement, property, component, and an entity, and so on. And this leads to the central idea of this research. So if construction teams repeatedly ask the same kinds of questions, maybe we should not only focus on modeling the data, maybe we should start modeling the question itself. And this is where the existing ontologies are very useful. So for example, the digital construction ontology, DiCon, describes activities, resources, states, agents, and processes, for example. ifcOWL and bot describe building elements and spatial structures. So the evidence side is already very well supported, but what is missing is the question side here. So which pieces of evidence are required, and how do we have to combine them in order to answer simple questions? And this is where this framework comes in. So it adds the demand side, basically, with request templates, information requests, flow constraints, and query patterns. So we're not trying to get rid of or replace any of these amazing like ontologies. We try to define how their data is used to answer these questions. And the important part here is that we do not start with the database, we start with the natural language question. And with that, we classify this question into a template. And after that, we bind the placeholders to project-specific context, and then we create the information request object, so that the question is no longer just a sentence, but it has a template, it has the bindings, constraints, and provenance in the end. And only then it is executed over the federated graph data, so that we can generate evidence-based answers to these questions. Now, with this supply and demand side distinction in place, we can now go ahead and actually split this question into two parts. So on the left, you see the recurring request pattern, and this is the stable part that can appear again and again throughout different projects and refer to different entities and activities. And on the right is the concrete side question, and this contains the project-specific terms here. And now this splits gets operational. So the template here on the left basically defines the reusable logic for the request. So in this case, number 34, for example, is a readiness question, and it defines which arguments it is looking for example, the entity and an activity. And it describes how these arguments have to or map to the underlying ontologies there. And the project instance gives us the concrete context. So entity equals foundation of one, and activity equals concreting. So the template basically tells us what kind of question we're asking, and the instance tells us what we're asking it about. And together they define the request even before we start querying. So we are putting like guarding rails into place to like secure the answer. Now let's have a closer look at the flow types, and this is where the readiness question becomes more than just a like basic status check, since ready is not the attribute you can simply query for. And for concreting, readiness depends on several supporting flows. And these flows are, for example, materials, prerequisite work, and external conditions, to name a few here. And these define the classes of evidence that are needed to answer the request. So these constraints do not say yet whether foundation F1 is ready or not, but they tell the framework where it has to look, basically. And each of these conditions can become a required or optional constraint, which means then the request is only ready if the required constraints have a matching path in the evidence path in the graph. So here we zoom into the required flow prerequisite work. So for concreting the prerequisite work is the reinforcement work for the foundation of one. And the framework can follow the evidence path from the product to the QA inspections and to the QA records, for example. And here they find the inspection in the state completed, but not in the state of approved. So this evidence path does not satisfy this constraint. So this would fail here. And this is the key result, basically, that once one required requisite fails here, the framework does not generate basically not ready, but instead it creates not ready because the prerequisite workflow approval is missing. And this creates an answer which is actionable for the team. So the team does not have to initiate a new search from scratch. The team now knows where to look and what to look for exactly in order to solve this issue. So to conclude, this framework is not yet or not a universal questioning answering system. We have three big limitations in place currently. First, the natural language is only like the entry point, so we need a robust classification from user input to the template selection. Second, the framework depends on these templates. So completely new question types still need to be modeled at this point. And third, the right templates needs reliable like project data and connectors identifiers. So in order to find the answer in the end. And these are basically the next steps. So natural language front end. So we heard a lot about the possibilities here. Then mechanism for extending the template and making it scalable, basically, and like connectors to the actual data. Then these are the main points I'm currently focusing on. And the long-term goal here is to create a request layer that grows with the stakeholder questions that are actually asked. And in this case, what are your questions here? So.